Welcome to another edition of Groundbreaking Discoveries in CALS. Last Monday, Kevin Walters talked to us about some of the history and the philosophy behind WARF. And today we have Carl Gulbrandsen with us, who has for many years, I think close to 17 years, been the managing director of WARF, and only recently retired, so he's very familiar with what has happened there over the last 20 years or so. Carl has a degree in physiology, but also in law, and he's one of those rare people who can sort of walk both sides of the issue. It's a pleasure to have you.
Thanks. So, people hear me? So I don't have any, this is hopefully going to be somewhat discussive if people have questions to ask. Feel free to shout it out. I don't have a prepared speech that I'm going to give, but I'm going to show you some slides and talk about what was an important discovery. Let's see if this, 20 years ago. And, you young people, if you listened well, if you were here last Tuesday and you listened, or last Monday and you listened well to Kevin, he probably already told you what the discovery is, but let me just say that it was an exciting discovery. It gave the potential to study one of the most basic aspects of human life, and it was considered at the time a biological breakthrough, promised a pathway to treating otherwise untreatable human conditions, but it was also a discovery that was laden with social and legal issues that potentially blocked its development and use. So who knows what that is?
Stem cells.
Well, you were there. Human embryonic stem cells, yeah. And what I'd like to, as a thesis of this talk, get through is that the university, a great public university, certainly was excited about this, but they were also concerned about what was going on. And there was a lot of turbulence that went on during the time that this discovery was getting rolled out. And so the title of my talk, WARF, UW, and the Nation, I didn't pick that title. David or somebody picked it. And I said to myself, well, what the hell am I going to talk about there? Actually, this is a good thing to talk about because WARF did play a role in this. People, Kevin talked to you a little bit about the history of WARF. WARF today is pretty much, as far as what its mission is pretty much the same as when it was founded. But WARF today, is quite a wealthy organization, almost $3 billion in assets. It does the patent and licensing for the university, manages money, and it gives a substantial grant every year. And so when people think of WARF, that's what they think of. WARF's the patent management organization, and it gives money to the university. What the story I'm going to tell is that there are other operational things that WARF does for the university and could do for the university at the time stem cells were isolated and cultured, that helped push the science forward. And it's truly, WARF's relationship with the university is a true partnership. And it allows a public university, which is an agency of the state, to do things that are a little bit more opportunistic, to have more flexibility than it otherwise would have as a public university. And the partnerships worked pretty well for 90 years. So, we probably should talk a little bit about stem cells. I'm hoping that people know. Have you studied what human embryonic stem cells are? Do you know what stem cells are? Stem cells are those cells and tissues that have the ability to reproduce themselves, but they can also produce a more specialized cell. And the ordinary stem cell, will produce a specialized cell of the tissue that it's located in. So if it's in the skin, it will produce skin cells. The human embryonic stem cell, however, This cell has something that's called pluripotency. It is able, if the signals are given to it appropriately, to essentially produce every single cell in the body. And the other aspect about it is that it's said to be immortal. You culture these cells, and as long as you keep feeding them, they will continue to divide, and theoretically, there's no end to their life. So it was a fascinating thing to have this discovery happen at Madison, Wisconsin. This is just a diagram of what a stem cell is. Progenitor cells are sometimes synonymous with stem cells. This is a progenitor cell that would produce blood cells, and it has a little bit more multipotency than an ordinary stem cell would have. But then you get to the stem cells, and this is a cartoon of how stem cells were isolated and then cultured. And what Thompson did was he used what's called the blastocyst stage of an embryo, and he extracted from the embryos the inner cell mass. And the inner cell mass become the human embryonic stem cell. In a developing embryo, as a human embryonic stem cell, they just have a transient existence, because that blastocyst will soon then divide into, produce a neural crest and a heart, and then start producing a fetus. But here, as you see in the cartoon, if they're cultured appropriately, if they're removed, cultured appropriately, if the right signals are given, they again can produce essentially any type of cell in the body. I want to also go back and talk just a second about WARF again. Kevin showed you this yesterday. This comes out of the charter of WARF. And these are my favorite lines in the charter. The opening line is kind of the overarching mission of WARF, which is to promote, encourage, and aid. I love that language. You know, the trustees, when they founded WARF, chose that language. It doesn't say we're just going to grant money. We're going to promote science, we're going to encourage it, and we're going to aid science. And then providing means and machinery. What a beautiful thing to say, means and machinery, to take these discoveries from the laboratory and move them to the marketplace. And, you know, maybe some revenue will come back to fund more research, but that was Steenbach's idea. And that's what the trustees ultimately accepted. And over 94 years, I think it's been a good relationship with the university, and they've had a fair amount of success, not the least of which is warfarin, which Tom is here to represent. But, you know, it's been a great history. So, going back to the human embryonic stem cell story, here are the kind of barriers that existed at the time of moving forward with the research. There's a funding barrier, and along with the funding is a legal aspect and then regulatory. And I'll talk about that a little bit. There is the moral, ethical, religious issue, and we'll touch on that. And then there are the politics. Politics in this case, you know, both threatened the university and threatened the science, but in the end they also helped the science. And we'll talk about that. So this is the first paper. We have to go back to '95. This is the first paper that Thompson published. And he published it in the Proceedings of the National Academy of Science in 1995, August of 1995. And this was about the isolation of primate embryonic stem cells, non-human primate embryonic stem cells. He used rhesus monkeys. Came to Madison from a circuitous route. You know, he did his DVM, you know, degree in veterinary medicine, and his PhD at Penn. Went did postdocs in Germany and another in the Wistar Institute at Penn. Then went out to Oregon. Had this idea that he could produce embryonic stem cells from monkeys, and he went to the Oregon Primate Center, which was going to be a good place for him to try to do this, but he was more interested in learning how to hang glide, and he didn't have time to work on it there. And then he learned about John Hearn at Wisconsin. And John Hearn had come to the Primate Center here from, I think he came from Australia. And he was internationally known. And he came here with the idea that he was going to make the Primate Center at Madison a great primate center, which he did. And he had some technology and was working in the area of thinking about stem cells. And it was a perfect marriage for Jamie to come here and work with John Hearn. John Hearn, left him alone, gave him the time to do the job he had to do, but he worked with rhesus monkeys. And there had been attempts to create primate embryonic stem cells in a state where you could culture them, but people hadn't been successful on that. They'd been able to extract primate embryonic stem cells from a blastocyst, but they just couldn't culture them so that they would stay alive. Jamie brought the magic secret with him, and he had the broth that could keep these primate embryonic stem cells alive and dividing. And then they would take them and they would inject them into a mouse, and it would form what's called a teratoma, just like a tumor within the mouse. And if you took that tumor out and you dissected it, you'd find that there was teeth buds in there and hair and muscle. And so it showed that these cells were pluripotent. They could produce all three germ layers of the body. That was 1995. So, the issue was, again, we're getting to funding, legal, regulatory, moral, ethical issues. Jamie had disclosed the primate embryonic stem cell success to WARF, and this was before I arrived at WARF. WARF filed a patent application. I think it was in 1996 that they filed the patent application. And I arrived in 1997. The situation that was being faced by the university and Jamie, originally Jamie wasn't, his goal wasn't to go to human, produce human embryonic stem cells. He thought that others would do that. And he expected that his publication in the Proceedings of the National Academy of Science would be widely read and heralded, and that there would be a lot of labs that would be moving in to work on this, and that somebody would eventually go to work on it in a human. But it was kind of just kind of laid there. It didn't get the kind of notoriety that he expected it was going to work, and so that he started to think about, well, maybe I should try to do this with human embryos. But the issue was that at that time, and today, at that time, you could not use federal dollars to do research with embryos. There's the Dickey-Wicker Amendment, and it comes in every year when the legislature, when the Congress is passing a law, this gets slapped on it, that says you cannot use federal dollars for doing research with embryos. So that was, with his primate embryonic stem cell work, he had been federally funded for that. He had federal grants, and they were still coming in, and he could do that work, but he couldn't move to the human embryos to do it. Wisconsin had an in vitro fertilization clinic, it still has, and so he knew that there was access to embryos, but funding was an issue. So he went to the university. At the time, we had a division in the university called University Industry Relations, and a fellow by the name of Price, what was his first name, remember? He ran it. Jamie went and talked to him, and he turned Jamie down. I subsequently learned that the reason he turned him down was fear of the moral, ethical, anti-abortion issues that would be surfacing, and he didn't want to get into that. Jamie never came to WARF at that time, and he had made his disclosure to WARF for patent, but he didn't think of seeing if there might be some money that WARF could spend, so they weren't asked about it. But within about a week of UIR turning Jamie down, Geron showed up on his doorstep. Geron was a small biotech company in California. A fellow by the name of Michael West, who was very creative, was a molecular biologist who also had a degree in the Bible. And he had started Geron with the idea of pursuing technologies that would delay aging or help people that wanted to anti-aging products that could make you feel young again. And he had been going around the country licensing up technologies. He licensed up some telomerase technology out of Colorado. When cells divide, there's these things at the end of the cell, the end of the DNA, that's called a telomere. And it appears that as the telomere, as the cell goes through multiple divisions, the telomere shortens. And when the telomere disappears, the cell dies. So he thought, well, telomerase could probably be the fountain of youth for us. So he licensed that technology. He went to Johns Hopkins, and scientists there by the name of Gerhard had, about the same time as Jamie was working, Gerhard had produced some, was working with were called germline embryonic stem cells. They were extracted from the fetus just as the germline was developing in the fetus. And so he licensed that technology. And then he showed up at Jamie's doorstep and he said, I'd like to fund you doing the human embryonic stem cells. And so Jamie entered into an agreement. There was a sponsored research agreement between the university, WARF was part of it, and Jamie, and Geron was going to pay for it, but that wasn't the only thing that allowed it to be done, because you still had regulatory issues. Now we're going from non-human primate tissue to human tissue, and human tissue, obviously, if you're working in a lab, is special. You got to treat it specially. And at the university here, we had the Health Sciences Human Subject Committee. They had to study this. Everybody, I think, at the time was concerned about what Jamie was going to do. And so the Human Subject Committee spent quite a long time, and I don't know if it took really a year, but it was close to a year of their studying whether or not this could be done ethically. It turned out that the study was also being done by the NIH, contemplating if somebody wanted to do this, could you do it ethically? Also, the agency in Canada, counterpart to NIH, was doing a study of it, and the UK. And all three studies were published before the Human Subjects Committee here made their decision, and all three were positive that there was a way to do this ethically. And so, I'm told that they didn't come to full agreement within their committee. There were people in the committee that thought that Wisconsin shouldn't be doing this, but they thought, well, we've got this to back us up, these three decisions. We might as well go ahead with it. And so in July of 1995, they gave him approval to proceed, but that wasn't the end of it. He still needed approval from the IRB. Jamie was sensitive about these things. He'd talked with Norm Faust, who was a bioethicist here, and had Norm consult with him on whether or not this could be done ethically. He also talked to Alta Sherrill, and he wasn't. He didn't ignore it. He felt he wanted to be very responsible about this, and he didn't want to get in trouble. He didn't want the university to get in trouble. Turned out Norm was the head of the IRB, and the IRB said, agreed that, yeah, we'll approve it, but then there are certain conditions. The conditions I've got up here is that you could only use excess embryos. So these are embryos produced in the IVF clinic. They produce for each patient a number of them. Not all of them are going to be used. So they would have to be embryos that were not going to be used to produce a child. There could be no payment made to the donors for use of the embryos. And then there had to be a detailed informed consent, And the embryos could not have been created for this research. So the embryos were created for implantation, and it's only if they were not going to be implanted that then the offer could be, the solicitation could be made is whether, rather than discard these embryos, would you be willing to donate these embryos to science? And so those conditions had to exist. And then turns out that Jamie got embryos from the IVF clinic here, but he also reached a consulting agreement or a collaboration agreement with a scientist in Israel by the name of Itzkovitz. And he also provided embryos from Israel that I'm assuming went through the kind of the same process that they're going through here. Itzkovitz had sent his lab manager or his postdoc to Madison, who worked for a year with Jamie, actually lived in Jamie's house, and worked in the lab to learn how Jamie was isolating these stem cells and was how he was culturing them. And then she went back to Itzkovitz's lab and carried on the work back at the Technion in Israel. Years ago, I gave a talk at a dinner for the Technion is for the Weizmann Institute, not our Weizmann Institute, but a Weizmann Institute in Israel. They had an office in San Francisco, and this was a fundraiser for the Weizmann Center. And the average age at the talk was after dinner. Average age was about 85, and there was three of us that gave a talk. There was a very well-known scientist from Stanford, Wiseman, I think his name is, who gave a talk, very scientific talk. Nobody understood what he was talking about, and you could see heads falling on the table. And then the bioethicist got up and read a speech for 40 minutes. And I mean, it was awful. And the one thing she said in her speech was that they should be happy that all of the human embryonic stem cells have a Jewish derivation. And I got up and I said, well, she's partially right. I said, I think 4 of the 5 stem cell lines are Jewish, but one I'm certain is Norwegian. It came from from the UW. There are also, so today stem cell research here at the university is governed by the SCRO committee, which is a committee of both lay people and scientists that look at what the research is going to be and whether it can be done ethically and morally. And there are also guidelines from the National Academy of Science that are followed. So he had success. In November 1998, he published his paper in Science magazine. And unlike the paper published in the Proceedings of the National Academy of Science, this was a big hit. I mean, people were just astounded at what had happened on both sides. People that are pro-life, anti-abortion, thought that Wisconsin was the kingdom of darkness, and that WARF was the prince of darkness, and they wanted to shut it down. But then others could see how important this research was and wanted access to it. A month later, WARF's patent issues, and this patent, for many, those that wanted to use the research and wanted to work in it, saw this as a big threat. And WARF really became the prince of darkness then. How could WARF patent this? And the day this patent issued, I got a call from the general counsel of NIH, who said that she had read this patent. And she said, when I read this, my conclusion is that these claims seem to cover also humans, not just primates, non-human primates. And I said, well, that's the way I read it too. And she said, I got to testify in front of the Senate tomorrow. They're going to be asking me about this. And years later, in looking through some of the archives, we discovered that in fact they tried to stop this patent. The patent office did. There was a petition filed in the patent office to withdraw the patent. And unfortunately for them, unfortunately for us, the patent had had issued and had gone to the printer. And at that point in the process of the patent office, you can't stop it. So it got out, but it was just by the hair of its chinny chin chin.
So it was staff people in the patent office?
We don't know who filed the petition, but we assume it was somebody in the higher up in the patent office.
All right, thank you.
Yeah. It was interesting to learn that. So the IRB also handed down some other restrictions, not on how you get the embryos, but restrictions on the research once you derived the human embryonic stem cell. And these restrictions were really restrictions that there were promises that were put into the informed consent that were given to the donors. So the promises were that you would not intermix the human embryonic stem cells of Wisconsin with an intact embryo, either human or non-human. I mean, you know, you've heard the mythological term about chimera. I mean, there was concerns about creating chimeric animals with these stem cells. And today, isn't that what we do with pigs? You know, we stick human genes in them so that they can produce organs that might be transplanted back into humans. But there was a real concern about that. There was a requirement that you could not implant these Wisconsin HES cells or products of Wisconsin ES cells in a uterus. And you couldn't attempt to make a whole embryo out of them. And during this time when WARF was providing material transfer agreements and licenses along with this to researchers to use the cells, I ended up at Howard Hughes. And Doug Melton, who is a very famous, prestigious scientist in Boston, he's an HHMI investigator, was at that meeting, and he was just berating me when I was explaining how our system worked and what they had to agree not to do. And he said, "You're telling me to do the very experiment, not to do the very experiments I want to do." And I said, "Well, there's not much I can do about that." I said, "You know, these are promises that were made to the donors, and you know, if you want to do those experiments, you can't do it with these cells, and you have to drive your own lines. You know, don't get them from us." And he was fumed about it, and for years and years and years, I'm sure he still is fumed about it, but he just really was angry. So the politics of abortion and politics of science. You know, as soon as Thompson's paper hit the press, the university knew that this was going to be a big thing. And Terry Devitt, who was a science writer for communications at the university, he actually had a desk for Jamie next to his in the communications office up in Bascom. And I think Jamie was there almost 2 weeks every day to help Terry answer questions from the press. At WARF, we had also a lot of issues, and we actually hired Andy Cohen to come in-house and deal with this. There was one day that I know he had 80 calls from the press around the globe. People were really wondering what the heck was going on. And then you had the politics in the state legislature. At that time, Tommy Thompson was governor, and the legislature, you know, like it is today, was pretty Republican. You know, I don't mean to demean Republicans, but it was pretty far-right Republicans, anti-abortion, and you know, pro-life, and you know, they were threatening to pass legislation that would prohibit research being done here at the university. You had a bunch of us. You know, I think either David Ward. I think David Ward was chancellor then. And I think that John Wiley was either provost or he was the dean of the graduate school. But at any rate, a bunch of people from the graduate school, and some people from WARF trounced up to the office and sat down with Tommy and said, you know, would you agree that you are going to veto any legislation that comes out? And he did. And he was powerful enough at that time that, you know, even though a lot of his constituents were very angry about the thought of this kind of research going on here, Tommy was strong enough at that time that he could say, this is important research, and, you know, we're not going to try to stop this. There was also lobbying going on in Congress, and you know, there was testimony being taken. There was certainly concern in Congress, and I've got a letter in my files from Arlen Specter questioning us about the wisdom of licensing Geron, who funded this research, giving them certain exclusive rights. And I actually had to go out and talk to testify in front of Specter on this issue. So one of the ways to deal with a lot of this, because the university being a agency of the state, being nervous about both what was going on in the state legislature, also being nervous about the fact that you still had the Dickey-Wicker amendment that said you could not use federal dollars for research with embryos. Now, human embryonic stem cells is past the research with embryos, but there was a gray area. Congress didn't know whether they would allow that kind of research to go on because it involved essentially destroying an embryo to get the intermass cells out. And so there was no release of federal funding to fund the work after the stem cells had been cultured. And there's pervasive federal funding at this university. There's not a laboratory in this university that doesn't have federal funding in it. And so the university was very concerned that if it was audited by the funding agencies, that there could be some real bad downside for the university. Well, in working with the graduate school, what we decided to do was, you know, let's create a private laboratory and move it off campus, which is what we did. We created, it was first called Wisconsin Stem Cell Institute. And the WARF trustees were nervous about that name because at the time, you know, you also had threats of violence. And they didn't want people working there to be in any kind of harm's way. So they changed it, and I think Virginia Hinshaw, who was the dean of the graduate school, came up with the name WICEL. So we changed it from Wisconsin Stem Cell to WICEL. And you know, the other things about not only having a place where Jamie could do research on human embryonic stem cells, not on campus and not in a state-supported facility, there was also the concern that there was such a demand out there that, you know, you couldn't expect, as usually happens at research university, the scientists will send out samples to colleagues at other universities. And it was felt that there would just be a crush of demand, and, you know, you'd have to offload that in someplace else. And this institute could also do that. So WICEL was set up to be a bank for the stem cells, to do research there, to also increase the number of cells to be frozen down and take care of the shipping out and keep control of this. But also, the last thing is that somebody had to monitor whether people were actually using these cells in an appropriate way. Were they trying to do the experiments that we promised donors they couldn't do? And so what ultimately was the solution was that a scientist could get these cells, and they would have to essentially sign a pledge that they weren't going to do these experiments. And then every year they had to certify that they weren't doing those kinds of experiments. If they didn't certify it, then we would follow up and find out what was going on. And in a few cases, if in fact they were doing it, they'd have to either return the cells or destroy them. In a few cases, we had that happen. So WICEL Research Institute was founded in '99. Took about half a year to get it up and running and going, and it had the three purposes that I just mentioned. And that's where it was located. Now, this pretty nondescript building at the time, that's located on Spring Street. It's about 2 blocks from the primate center. So Jamie would work on his non-human primate cells in the primate center, and then he would toddle down to Y cell, which is in this nondescript building, and work on the human stuff. And this building was an AT&T switching station. But in the years that this building was around, the need of space by AT&T for switching apparatus had decreased, so that by the time we arrived, they only used about a quarter of the building. The top floor of the building, second floor, had been built out as a laboratory for the state hygiene lab. And they had built a new building on the west side of town, so they were vacating it. So it was an opportunity for us to lease nice research space for a low price. And I tell you, negotiating a lease with AT&T, particularly when it involved research on human embryonic stem cells, was not easy. But we got it done. We started out with 1,200 square feet. That's where the liquid nitrogen was that froze down the cells, and so that was the banking and the shipping place. That was also, they had a couple banks for doing research and some hoods and stuff like that, and Jamie did that. So I want to show this. I mean, I mentioned that Tommy Thompson was supportive of biotechnology. This is a picture taken actually here in this facility. Thompson had the BioStar program, and this facility was one of the BioStar buildings. And he was on a tour here, and that's David Schwartz, who's a geneticist here. And Tommy was looking at this. And then he heard a talk from Mike Sussman, who's in the biochem department here, but he's got his labs here. He runs the genomics center. And he liked listening to Mike give his spiel. And so he said to Mike, I want you to come up and tutor me in biotechnology. So Mike, on a periodic basis, would traipse up to the Capitol and have a session with Tommy to kind of coach him in biotechnology. And, it paid off, because then when Thompson came along, Tommy visited Y cell. There he is at Y cell. The lab technician, Leanne, is showing him a plate with stem cells in it. This picture, Tommy's looking at it. These other people with Tommy are all from NIH. That's the other thing he did. When he got to Washington, he said, people at NIH don't know where University of Wisconsin-Madison is. And he brought a whole crew of people out here, like 20 people, took them around and showed them that, we really have an operating university here that's as good as what you got on the coast. But at any rate, he visited Y cell. And then, in March 2001, just before we, it was after we organized Y cell, but probably before we moved in, a second patent issued to WARF. And this patent was what's called a continuation in part of the earlier patent that issued. This patent has specific claims to human embryonic stem cells. Another thing to make both the scientists and the pro-life groups angry and mad. The scientists didn't like that we're not part of Wisconsin, didn't like the fact that WARF was patenting this. And I'll tell you one reason why WARF did it. I mean, when I wasn't here when the non-human primate stuff came into WARF, so I don't know what the discussion was at that time. When Jamie disclosed that he had succeeded with the human embryonic stem cell, he told me, I don't know what is going to happen with this. Whether all these potential therapeutic uses will ever occur. But I do know that this is an important research tool. And practically every developmental biology group is going to want to have access to this. And the issue that we faced at WARF, there were concerns on the WARF staff that again, this was patenting human life. And should you do that? NIH did a study and decided that this was, you know, as long as you had these precautions, it was okay. You know, these would never be human beings. The issue was that if we didn't patent it, Geron would patent it. And who's going to have control of it? Do you want this biotech company, Geron, to have control? Or do you want to have the university have control? And I've always felt that about patents. Patents, to some extent, if you understand it well enough, fit in with academic freedom. At least the way we do it at Wisconsin. It allows a researcher to establish their own agenda and not somebody outside with a patent that's going to establish their agenda. So that was one reason why we did file a patent application. This is a picture of Tommy testifying in Congress about human embryonic stem cells. And this is George Bush. You know, on August 9th, he held a televised talk to the entire nation about why he was going to fund the existing stem cell lines. You know, I don't know that there's been many talks by presidents to the nation about a scientific discovery. And how did he get to this? I mean, George Bush initially was against it. And he had Tommy whispering in his ear and Karl Rove whispering in his ear. Rove saying, you know, you can't do this. You know, you're going to offend important constituents you have. And Tommy saying, if you don't do this, people are going to say, you halted medical progress. And people are never going to forget that. So they came up with a compromise, and the compromise was to fund the presently existing lines, but not fund the derivation of any new lines or fund the use of those new lines. Scientists were, outside of Madison, were enraged about that. I mean, they felt that this was absolutely wrong. They should fund it all. But it did open the door to federal funding. And where did the federal funding come? To Madison. Tommy, I'm sure, helped make that happen. Wisconsin got a national exploratory stem cell license, several millions of dollars to begin with. And then there was a competition for a national stem cell bank. It was a competition, but we were the ones that had 5 of the important lines, the most tested lines, the most studied lines. And YCell got that contract. It was a 5-year contract, about, I think it was about $9 million a year for 5 years. And during that period of time, you know, in order to get the contract, we had to do an agreement with the Public Health Service, and they were concerned about it. We spent time working with them to make sure that their concerns were addressed and our concerns were addressed. Bioethical restrictions remained. The intent was to make these stem cell lines as widely available as we could. There was agreements that both sides were comfortable with, and that if somebody else had stem cells that they derived, we would give them a license under WARF's patents. We weren't going to preclude them from doing that. The other thing that we had with the agreement was that we would make sure that the cells were provided for a relatively low cost. Initially, when YCell provided these cells, they charged $5,000 for a shipment of the stem cells. And my feeling about it and the feeling of others at YCell about it at that time was that there's virtually no experiment you can do today for less than $5,000. And these cells are immortal, so you pay it once and you have them forever. And the other thing is that if you aren't going to have any skin in the game, we don't know what you're going to do with these cells. If you're going to spend $5,000 on it, then theoretically you're going to respect it and you're going to do the research. So we charged $5,000, and that just drove the other scientists crazy. you know, we should be getting this for free. So the deal with NIH was that we would charge $500. And that was satisfactory. We had not a lot of pushback on that. They were still angry that YCell controlled this and that Wisconsin had, you know, these important lines.
You mean others in the scientific community?
Yeah,
Okay.
yeah. And in fact, you know, our stem cell patents were challenged for the entire life of the patents. We were in litigation in the patent office about the validity, and we won all the time. I would question today whether we could get these patents with the present Supreme Court, and you know, again, and sneaking through the petition to withdraw. That was interesting. So this is a cartoon of where YCell is today, and it shows where they've shipped lines. And these are the things they do today. They don't do stem cell research per se today, because now you can do any research that they were doing at YCell you can do on campus, because the restriction of funding the stem cells derived has gone away. But it's still, you know, there's still tensions because our present legislature still doesn't like that. And so we do worry about that. But they've shipped, you know, as it says, they've got 1,200 lines in their inventory. They've supplied these lines to hundreds, actually thousands of researchers. And actually, what YCell has done, you know, distribution of 6,000 researchers, 2,500 investigators, 6,000 distributions at 800 institutions, 45 countries. And they've trained a substantial part of the scientific population that works with human embryonic stem cells. For years, YCell ran a training program where people would come in and they would teach them how to use it. And the other thing they provided, and they still provide, is technical assistance. So if you can't get these cells to be cultured and you're having trouble with them, somebody from YCell, they'll talk to you on the phone. If they can't do it on the phone, they'll go to where you are at and make sure that you can use the cells.
Including South Africa, Brazil, Argentina.
Well, we might have them come here. But you know, YCell does go to all the major conventions and they meet there. And they are viewed, the people out there have done a terrific job. They're viewed as really the gold standard in banking and distributing cells, and highly respected. So, and they're somewhat self-sustaining. So that's where YCell is today. It's a little bit different than the place that they had before. It's a very, very beautiful laboratory. It's out at Research Park. And they got a great staff. They do great stuff. So the other component of it, you know, I told you people were angry. People also wanted to own it. This was a Phil Hand's cartoon that this was occurring at the time California was coming out with what's called Proposition 71. Proposition 71 was a referendum in California to spend $3 billion in stem cell research. And that prompted Phil to write this cartoon. And in fact, the measure passed in California. And in fact, I think today there's another measure that's coming out. They want to raise another $2 billion. The concern was when they floated Proposition 71 in California, Jim Doyle didn't want the universe for stem cells to leave Wisconsin and move to California. He wanted to keep it here, so he had a big press conference in this building, I think. Yeah, and he announced that he was going to spend something like $370 million on research projects and facilities to make sure that we continue to do the work that we were doing in stem cells. I don't know that he spent that much money, but that was kind of the thing that was the igniter for building the Wisconsin Institute for Discovery. It got the Mortgages excited. They wanted to see this happen. They wanted to see stem cells remain important here. They really wanted to support the research that was going on. So they came here, talked to John Wiley, who was in Chancellor, went up, talked to Doyle and said, we're willing to make a substantial contribution to make this work. And after some fits and starts, WARF ultimately got involved too, and WARF anteed up a fund to help make the Wisconsin Institutes for Discovery a reality. And I think the building is working pretty well. So this is the induced pluripotent stem cells. About 10 years later, Thompson succeeded on this. And this kind of gets in the politics of science because Thompson published on the same day as Yamanaka in Japan published with the induced pluripotent stem cells. And frankly, Thompson beat Yamanaka. He submitted his publication several months before Yamanaka submitted his. And Science magazine sat on it because they knew Yamanaka was working and they knew that he was close. And so they made a deal with Nature magazine that when Yamanaka got his publication in, his paper in, that they would publish on the same day. And that happened. And Yamanaka, of course, got the Nobel Prize. Thompson didn't get it. And there's probably a number of reasons why Jamie didn't get it. He certainly deserved it. But I think one of the reasons is that induced pluripotent stem cells, which are derived from fibroblast cells or whatever, they skirt the moral ethical issues, the anti-abortion issues that human embryonic stem cells have. And the people at the Nobel in Sweden don't want to get involved in something that is kind of messy, certainly something like a potential abortion issue. So, that's the way it is. But at any rate, we're proud that it happened here. And, we know the facts. You don't like them, but that's the way it is. So today, this is the web page for the Stem Cell and Regenerative Medicine Center at the university. And there are about 100 researchers that are listed on that site as doing some aspect of stem cell research. And, we've got some really strong scientists here, David Gamm and the Eye Institute, and Tim Camp over in the med school, and John Odorico. Odorico does works with diabetes, trying to produce pancreatic stem cells. He's got his own company. Tim Camp, he's working in the heart issue area. And then David Gamm, he's also started a company with Fujifilm to produce cells to treat retinal disease. And we've got a number of companies in town. Cellular Dynamics, which is owned by Fujifilm now, and the rest of these are, some of them are out at Research Park, some of them are other places, but it's really done quite well. And so what's the future of stem cells? So everybody thought that stem cells would go away, but there are clinical trials occurring right now in the areas I've listed up here: retinal degeneration, spinal injury, congestive heart failure. And they're all using human embryonic stem cells. And the hope, I think, for a lot of people is that ultimately they will be transferred to induced pluripotent stem cells. But they're finding that the human embryonic stem cell is more predictable than the induced pluripotent stem cells. And it's probably in part because you take a adult stem cell, say from your skin, and reverse engineer that to be a embryonic stem cell, induced embryonic stem cell. It still carries with it all the mutations of the adult, whereas with the human embryonic stem cell, you're starting at the very beginning. And so the human embryonic stem cells remains the gold standard. If you're really studying human development, that's the best cell to use, not the induced pluripotent stem cell. So we'll see how this plays out. They're still important, and Wisconsin's still kind of maybe not the center of the universe, but it's still an important center for stem cells. So, questions?
Thank you very much.
I have a question. I had no idea that the Discovery Building, well, I kind of knew the mortgages had helped fund it, but are you saying that the center, the stem cell center is actually, some piece of it is cited within the Discovery Building?
So one of the things that
Even though some faculty members or people associated with it are in the various departments?
One of the things that the trustees required is that a portion of that building, it's actually 2/3 of the building, be completely private. So there was land swapped with the university when that was built. And that's where Jamie Thompson's labs are.
Okay.
Now, if they outlawed stem cell research at the university, I mean, you know, would we have space to move all the other researchers in? I don't think so.
Yeah.
Would it save stem cell research for Madison just because you got a private? I don't think so. But it does, you know, who knows what other science is going to come along that people aren't going to like, artificial intelligence or something like that. You know, that, I mean, you know, when you think about discoveries that created all kinds of angst among people, in my lifetime, the only thing that comes close is the Cohen-Boyer DNA recombinant research. When that happened, people thought that scientists were going to be making really nasty bugs or something like that would get out in the environment. And the city of Cambridge, Massachusetts, passed an ordinance that said you couldn't do the research within their city limits. And the scientists got together and worked out controls so that people were relaxed a little bit and those ordinances got reversed. The difference between the DNA recombinant research, which was, and the embryonic stem cells, is abortion. It's the anti-abortion issue, and you didn't have that with the DNA recombinant research, but it was still scary stuff. And now we got, you know, we got Weissman now producing Ebola virus vaccine, and you've got Yoshikawa Oka out in the research park working with pretty nasty things. So there's all these things that go on, and we get it done. You know, my point of this is that a public university needs help to do this stuff, and you know, the people who run the university really want to get it done, but they also worry about, are they going to get a good budget from the legislature if they're doing this, or yes. So, and organizations like WARF that are not part of the university but are affiliated with the university, that's something that they help do that a lot of people don't think about. It's not just giving money. It's actually helping create the machines and the mechanisms to keep it going forward.
So when the Bush compromise came along, there were just 5 or 6 or 7 lines of cells that could be used in any place?
Actually, I think well, we had our 5 lines here, which were the most widely studied lines. I think at the time there were actually 22 lines. And you know, we had the advantage because of all the work that had been done with the 5 lines, and then we got to be the National Stem Cell Bank.
So that's changed, isn't it? That is the Bush doctrine isn't in place. Can anybody who wants to now develop a way of deriving his own embryonic stem cells?
Yeah, but the federal government won't pay for that.
Still won't? They
will pay for the research with the derived stem cells, but they won't pay for the derivation. The Dickey Wicker Amendment still sits there. And they, you know, every presidential administration does its own study on it. When Obama came in, they had to restudy this. And we had to resubmit everything to the Obama administration to show what the provenance of these cells were and the, you know, the informed consent and all this. So,
are there cases now where graduate students or postdocs split their time between a university laboratory and a private one?
Well, the case here would be the Mortgage Institute for Research, because I think every principal researcher at Mortgage is also, except for one maybe, is also a faculty member here at the university. And they may have, and they would have a home in a department here. And you know, even the head of the mortgage, Brad, he's got a lab over in biochemistry or biomolecular sciences in a lab at, I think that's where his lab is. I don't think he has a lab at Mortgage.
Did I hear you say, did you say that the stem cell patents have run their course or?
Yeah, they're expired now, except that we've got.
You didn't renew, and the decision was to not renew them, or why would you? Because
well, you can't renew a patent, it expires.
Right.
But we have follow-on patents that are method of use patents, and the magic broth that Jamie used to culture the cells, that was patented. And that's been licensed. There's a number of licenses that YCell has and that WARF has in this technology to companies and to schools. Tom?
I'd like to point out that this is the lectern from which Jamie announced the discovery in
Is this?
1998.
Oh.
He was here. And are we going to do anything for the 20th anniversary?
Yeah. So on April 18th, there is a symposium at Promega, and Jamie has organized who's going to speak at that. And what he's done is he's bringing in researchers from around the country that are involved in clinical trials with the human embryonic stem cell. So that'd be very interesting. And then that night there's a big celebration over in the Discovery Building.
And then how much money have these royalties amounted to from the licenses?
You know, it's not that I want to be confidential. I don't. I really don't know. My suspicion, I think they paid for themselves, but not hugely. It's nothing like the vitamin D patent of Hector DeLucas. But you know, WARF in licensing Jamie's company CDI, which then was bought by Fujifilm, WARF also had equity in that, and so they made money back on that. And you know, because of the need to keep the cost low for researchers that were using it, there was an effort to try to make a lot of money on it. There was some anger from people that were associated with trying to push the technology that we would not, after Geron, we did not give any further exclusive licenses under this technology. We did with Geron, and it's like any new technology, you really don't know how important it is when you start out. So WARF licensed more rights to Geron than it should have, and it turned out Geron couldn't do all of it, and so we decided that we were going to pull that back. We ended up in a lawsuit, and the result of the lawsuit was a settlement where we trimmed the license back and we clarified things. And then Geron took it all the way to clinical trials just with acute spinal injury, and then ran out of money and went out of business. And that license and the data and the study went to a company called Biotime in California, and they're still trying to develop this. So,
I think that's a big point to make, is that, you know, unlike the original vitamin D patent or the warfarin patent or the vitamin D Hector DeLuca derivatives, this is not on the list of grand slams for WARF.
no.
And that there are reasons
Yeah.
for that.
And the importance of it. I mean, you know, the big goal is to get the technology utilized and out the door. And I think WARF succeeded with that. I think that, you know, there's intangible values too. I mean, look at all of the researchers here at the university that are using this technology today and bringing in federal grants. So if you started looking at the amount of federal dollars that came in because of this, I think it's pretty high.
Yeah, but that's why I specifically asked you about royalties.
Yeah.
Because, you know, we know the $900,000 figure from 1927, got an idea of what the
Yeah.
patents
Yeah.
brought in, but or not human embryonic stem cell patents are not in that.
And it's, you know, it's because it takes a long time to develop this stuff, and there was a lot of things that had to happen, and you know, I think that we learned a lot along the way. I certainly learned a lot along the way. Kevin, you know how much we need?
Yeah, I looked it up. As of 2015, embryonic stem cells made $25 million.
Okay.
So it's gone up since then. It is an ongoing portfolio. That places it sixth in inventions over the 90 years. So by comparison, and just through inflation, warfarin made about 170 million. Steenbach patents made about 218 million. And then Hector Luca's inventions were about 600 million.
Yeah.
So can you repeat those numbers for the recording? It was 25 million for
25 million for the revenues on stem cells.
100 million for warfarin.
100 million for warfarin.
inflation adjusted.
Inflation adjusted. 170 million for Carl Paul Link, inflation adjusted.
220 million for Steenbach, inflation adjusted.
220 million for Steenbach, inflation adjusted.
And around 600 million for DeLuca.
600 million for DeLuca. Yeah.
And Kevin, where'd you get those numbers?
Those are internal WARF numbers. We calculated based on.
Oh, we're gonna have to destroy that film. Yeah. Tom.
What is the contribution of WARF back to the University of Wisconsin per year, more or less?
Today it's a little over $100 million a year. Yeah. Yeah. And you know, the reason WARF can do that is because early on, as Kevin pointed out in his talk on Monday, there was the decision made that you should start a fund and invest that. And there was a battle, as Kevin could tell a great story, a battle between Brittingham and Steenbach as who was most important to WARF, Brittingham's investment acumen or Steenbach's science. Yeah. And it finally ended because Brittingham had a heart attack and died. But you know, I think they're both right. I mean, they started with Steenbach's invention, and over 10 years they made 14 million off of it, and then Brittingham invested that in public equities after the Depression, most of it. And it did really well in 10 years at 14 million. When I was at WARF, I did the calculation. If you took that 14 million and you increased it at compounded it at 5% semi-annually and took it up to the present, you'd have about the same size investment portfolio that WARF has today. That's, you know, the compounding effect over 94 years is pretty good.
I do have one question. Your whole story, you just touched on a little bit of when the stem cells were unveiled, and how the legislature and even the federal government, Thompson, and the U all got themselves into a bundle. I just wonder if there has ever been a long-form journalism piece that goes into detail about that, or maybe an article that was ever printed in the State Historical Society's quarterly magazine, or even a student's dissertation, or that went into.
Not that, but I think it's a good story because it does show how an outside institute can help a public institute act more like a private institute.
Yes.
And you know, we compete with Harvard and MIT and Stanford that are all private.
Right.
They can do a lot of things that it's difficult for a public university to do. So, great. Oh.
Basic question. What defines a stem cell line? What distinguishes one cell line from another?
It's really the original embryo that it's derived from. So, you know, and they have their own personalities.
The cells?
Probably not, you know, not drastically, but like the most important lines of the 5 original lines that were created are the H1 and the H9. They're the most predictable, most reliable. And H9 is good, I think, for deriving neurons and so forth, and H1 for heart and stuff like that. but you know, you can use them for anything, and they have. So it is interesting. It's, you know, there's some art to the science, right? You learn that through the data that you acquire on the lines and through studying them. But then people start to recognize it. One thing that YCell does is if you go on their site with respect to looking at lines, they have the provenance of it, and then they list the studies that have been done and people that, what people say about it. And so when people go online to order, they get some background information about the lines before they order them.
So the Thompson lines have been around for years now.
Mm-hmm.
Still in use.
Yep.
So they're immortal, but they're not resistant to mutations. Don't they, after 100 generations, start to get riddled with mutations?
Yeah, it's so they expanded the lines and froze them down. So the lines that were early on,
So
I mean,
go back to the
if you get beyond 40 replications, then you start getting into problems. And one of the things that YCell did and still does is that before they send stuff out, they've done the cytogenetics on that to make sure that what they're sending you is what you think you're getting.
So around campus, there's some plaques that talk about the Luca and Steenbach. Are they for Thompson?
I don't think we have a plaque for Jamie Thomson
You know,
yet.
I think those plaques, they may be all for CALS. Is that possible? I think
For who?
CALS.
Oh, yeah, okay.
No, there's a whole set of them, Dave, up on Baskin Hill also.
And isn't there? I think that the Alumni Park, that there's some stuff on
Could be there.
Thompson.
I
Yeah.
think the plaques were done around, 2004, 2005, somewhere like that. So it turns out it's pretty new.
Okay.
They weren't historical, that's so long ago.
But there have been ones, the Oliver Smithy's plaque here at our building was put up after he won the 2007 Nobel
Yeah.
Prize. So
They're nice plaques. I like to go around and read
Yes,
them.
they are.
Yeah.
They are.
So,
Take your guess.
yeah, well, thanks a lot. Let's see.
Is there information at the Science Museum at LATC about Jamie Thompson?
The Science Museum has a Hall of Fame.
Yes,
60 people, but one of the qualifications is you have to be dead for that. This is the way you avoid having people fight over who number one is.
So, how do I get out of here?